Hello everyone, next come to the gamma function. It's an important definition. Gamma is also important definition. If n is strictly greater than 0, then the integration 0 to infinity x to n minus 1 into e raised to minus x into dx is said to be a gamma function with the condition must and should n is strictly greater than 0. Okay, that is called as this integral is said to be a gamma function of n. It is denoted by gamma. It's a half t. Otherwise, you have to use a gamma of n. That's said to be a gamma function. See, compared to the beta function, here for a gamma function, the limit is 0 to infinity. For a beta, it is a 0 to 1. And the function is x raised to n minus 1, e raised to n minus x is the, for a gamma function. For a beta, it's the x raised to n minus 1, 1 minus x raised to m minus 1, 1 minus x raised to n minus 1. If the function integral is in the form of x, 1 minus x, that is the beta function. If the integral function, if in the form of x, e raised to exponential, for if it is in the form of exponential e raised to minus x, that must be a gamma function. Okay, once again I will repeat. If integral have a e raised to minus x, then that is a gamma function. If integral function it has in the form of x, 1 minus x, that is the beta function. Okay, for a gamma it is the limit is 0 to infinity. For a beta it's a 0 to 1. So this is the gamma function. Once again I will define how to define gamma function. If n is strictly greater than 0, then the integration 0 to infinity x raised to n minus 1 e raised to minus x into dx is said to be a gamma function. Okay, and it is denoted by gamma of n. Okay, that is a half t, or otherwise you have to use gamma of n. Okay, therefore that is the gamma of n is equal to what? Integration 0 to infinity x raised to n minus 1 e raised to minus x into dx, where n is strictly greater than 0. So that is the gamma function. The gamma function is also called as a second Eulerian integral. Okay, as a knowledge purpose, gamma function is what? It is also called as a second Eulerian integral. Okay, let's see some example. Expressed in the form of integral can be expressed in the form of gamma function. Then how to solve? First example, integration 0 to infinity x cube e raised to minus x into dx expressed in the form of gamma. See here, by the definition, the limit is 0 to infinity. The x power is 3, but our definition is what? N minus 1. Then the next term, n minus, if the x power is n minus 1, the next term is the gamma of the n. That is the, here x power is cube, that is 3, then 3 plus 1 we get a gamma of 4. E raised to minus x is same. The power, the gamma function is depend on only one term, that is the n, that is the x power, depend on the x power. Okay, for a beta it is a depend on x and 1 minus x, but here gamma function has only one variable, that is the n. x raised to n minus 1, that is 3, n minus 1 equal to 3, then n equal to what? 4, therefore gamma 4. Second example, integration 0 to infinity x raised to 2 by 3 e raised to minus x into dx. Compared with the definition, limit is 0 to infinity e raised to minus x, e raised to minus x, dx as same. But compare with the power of the x, that is here 2 by 3, by the definition we have a n minus 1, n minus 1 equal to 2 by 3, then what? N value, that is the next term, 2 by 3 plus 1, that is the, take a LCM, we get a 3, 3 ones are 1 3 is, we get a 5 by 3. So that is the gamma of 5 by 3. Okay, take one more. See here, another book have used as a simply gamma. It's not a square root, it's a half square root. Okay, it's using in the symbol, you have to use this type or a half t. Okay, receive your opinion. Take one more. Evaluate or express in the form of gamma function, integration 0 to infinity e raised to minus x, x raised to 7 into dx. See here, once again, limit is same, e raised to minus x is same. They depend on only the x power. The 7, the next term is what? 8. That is the gamma of the x power n minus 1. The next term is n. Therefore, gamma of n is a gamma of 8 directly. Okay, next. Integrate 0 to infinity e raised to minus x, x power is r into dx. The next term is what? That is the n, that is the gamma of r plus 1. Okay, take next one. integration 0 to infinity e raised to minus x raised to 6 by 5 into dx. Okay, the 6 by 5, the next term is 6 by 5 plus 1, that is the 11 by 5, gamma of 11 by 5. Next one, integration 0 to infinity e raised to minus x raised to 7 by 9 into dx. Integration is, limit is same, e raised to minus x term is as it is, that depend on only x power, that is 7 by 9. 7 by 9 is what? That is the n minus 1. The next term is the gamma of the n agutto. Therefore 7 by 9 plus 1 is what? Take a LCM, we get a 16 by 9, gamma of 16 by 9. Okay, so this is the some examples on gamma function. Take some note. See, it's note, this note is very important. They will ask for 2 marks. Show that gamma of 1 equal to 1. Okay, they will ask for in question paper for a 2 marks. Gamma of 1. How to define gamma of n? It is the integration 0 to infinity e raised to minus x raised to n minus 1 into dx. Here n is the value is 1. That's why I am taking here integration 0 to infinity e raised to minus x raised to n. I put in the 1 because they given gamma of 1. N is a 1. Therefore 1 minus 1 into dx. Then 1 minus 1 is a 0. We get a integration 0 to infinity e raised to minus x raised to 0 into dx. X raised to 0 is 1. Then we get what? Integration 0 to infinity e raised to minus x into dx. Then what is the integration of e raised to minus x? That is e raised to minus x divided by minus 1. I am taking as in a numerator, that is minus e raised to minus x. Apply the limit. First apply upper limit infinity. We get a minus e raised to minus infinity minus of minus e raised to x power is the x value is the 0. Then e raised to minus infinity taking as the, and the power is negative, then taking as the, in the positive, that is the 1 divided by e raised to infinity. E raised to infinity value is infinity. Then 1 by infinity is what? 0. First term is 0. Then e raised to 0 is value what? 1. Minus of minus is plus. We get a 1. Therefore, gamma of 1 equal to 1. So, this is the proof of the solution of the example. It's a very important. They will ask for 2 marks. Okay. Next, come to the recursion formula for gamma function. It's a very important question. They'll ask these two proof. Okay, first we will take the first proof. Prove that gamma of n is equal to n minus 1 gamma of n minus 1, where n is strictly greater than 1. What is the proof? Gamma of n is equal to n minus 1 gamma of n minus 1. Okay. We know that definition is what? Gamma of n equal to integration 0 to infinity x raised to n minus 1 into e raised to minus x into dx. Okay. Here I am using integration by parts formula. Okay. X raised to n minus 1 as it is. E raised to minus x integration is what? E raised to minus x divided by minus 1. Now apply limit 0 to infinity. Second term minus integration 0 to infinity x raised to n minus 1 differentiation is n minus 1 x raised to n minus 2. Then once again e raised to minus x integration is e raised to minus x divided by minus 1 into dx. Okay. Apply the limit. See here, if you apply the, I am taking as a direct, they will taking as a x raised to n minus 1 e raised to minus x taken in the denominator, that is the e raised to x. Okay. Here you have to take directly. If you put x equal to infinity, you get e raised to minus infinity, that is 1 by e raised to infinity is once again a 1 by infinity, that is a 0. If you putting the infinity, you get a 0. For a second, x equal to 0, you get a once directly 0. If putting infinity and 0, you get a first term is a 0. What is the second term? See here, already minus 1 is there, a minus 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 plus. Constant term take outside, that is the n minus 1, remaining term is integration 0 to infinity e raised to minus x raised to n minus 2 into dx. Okay, the constant term as it is n minus 1 e raised to minus x. See here, the x power is n minus 2 into dx, but with definition is what? If x power is n minus 1, the next term is, that is a gamma function, that is a gamma of n. See here, the x power is n minus 2, then the next term is what? That is a n minus 1. Okay, n minus 1 as it is. By the definition of the gamma function, 0 to infinity e raised to minus x raised to n minus 2, its next term is adding the plus 1, we get a n minus 2 plus 1, once again a n minus 1, that is the gamma of n minus 1. It's a very important, they will ask for 2 marks. Prove that gamma of n equal to n minus 1 gamma n minus 1. Okay, that is the proof of the next. Take down corollary. This is also important. If n is a positive integer, then gamma of n is equal to n minus 1 factorial. Okay, but previously you have to prove that gamma of n equal to what? N minus 1 gamma of n minus 1. Okay, for a corollary is what? Gamma can be expressed in the form of factorial, that is n minus 1 factorial. Okay, using the previous proof, we know that gamma of n equal to what? N minus 1 gamma n minus 1. Okay, putting n minus 1 is as it is. What is the gamma of n minus 1? Once again applying, we know that gamma of n equal to n minus 1 gamma of n minus 1. Put that value for n as a n minus 1. N minus 1, we get what? The next term is the n minus 2 gamma of n minus 2. Okay, the constant on 2 n minus 1 n minus 2 as it is. Once again a gamma n minus 2 is what? N minus 3 n minus 3 gamma of n minus 3. Continue that process, we get a n minus 1 n minus 2 n minus 3 so on up to 1 gamma of 1. Okay, what is the gamma of 1? Already you know that in note gamma of 1 is 1. We get a n minus 1 n minus 2 so on up to 1, that is in the form of factor, we get a n minus 1 factorial. So that is the proof of the corollary. Okay, they will take proving there. Once again a gamma of 1 equal to integration 0 to infinity x raised to, they will prove in the previous note that term gamma of 1 equal to 1, therefore gamma of n equal to n minus 1 factorial. Okay, take down some note here also. If n is a positive fraction, then gamma of n equal to n into 1 into go on to decreasing by 1. The series factor continues the here. For example, gamma of 7 by 2, that is the gamma of n. Applying that previous proof, gamma of n equal to n minus 1 gamma of n minus 1, that is the gamma of 7 by 2. The minus 1 7 by 2 minus 1 once again a 5 by 2 gamma of 5 by 2. 5 by 2 as it is. Once again a gamma of 5 by 2 is what? 3 by 2. 5 by 2 minus 1 is a gamma of 3 by 2. Continue that process until you get a decreasing by 1. Okay, 5 by 2 3 by 2 once again. Next gamma of 3 by 2 is what? Gamma of n once again apply n minus 1 gamma of n minus 1, that is the 3 by 2 minus 1. We get a 1 by 2, that is 1 by 2 gamma of 1 by 2. Okay, so this is the process to find out the gamma function. Okay, so this is the very important, it's a very important, these two proof are very important. Gamma of n equal to n minus 1 gamma n minus 1, and the another one is in the form of factorial gamma of n is equal to n minus 1 factorial. They will ask for 2 marks questions. Okay, on next class I will explain the some more example. Okay, thank you.